December 7, 1941, 2:30 p.m. Tokyo Standard Time. Imperial Japanese Naval Headquarters, Tokyo. In a conference room overlooking the Imperial Palace Gardens, Admiral Osamu Nagano stood before a wall-sized map of the Pacific Ocean, red pins marking the smoldering remains of the United States Pacific Fleet at Pearl Harbor. Around the mahogany table sat the most powerful military minds in the Japanese Empire, men who had spent decades studying naval warfare, men who believed they had just delivered a knockout blow that would force America to negotiate peace within 6 months. What these officers celebrated in that moment would prove to be the most catastrophic miscalculation in modern military history, a miscalculation so profound that within 3 years, American shipyards would be launching aircraft carriers faster than Japan could build destroyers, transforming the Pacific War from what appeared to be a Japanese triumph into an industrial avalanche that no amount of courage or tactical brilliance could withstand. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. The mood in that Tokyo conference room was jubilant yet cautious. Admiral Isoroku Yamamoto, architect of the Pearl Harbor attack and commander-in-chief of the combined fleet, sat at the head of the table reviewing damage reports transmitted from Vice Admiral Chuchi Nagumo's strike force. The numbers exceeded even optimistic projections. 8 American battleships had been sunk or heavily damaged. The USS Arizona had exploded with such violence that over 1,000 sailors remained entombed in her hull. The USS Oklahoma had capsized, trapping hundreds more. The USS California, USS West Virginia, and USS Nevada were settling into the harbor mud. American air power in Hawaii had been decimated, with over 200 aircraft destroyed on the ground. Yet Yamamoto's expression remained somber while his subordinates celebrated. He had studied at Harvard University in the 1920s and served as a naval attaché in Washington. Unlike many of his colleagues who had never visited America, Yamamoto understood something that the damage reports from Pearl Harbor could not capture. He had driven through Detroit and toured industrial facilities in Pittsburgh. He had witnessed the casual abundance of American life, the miles of automobile factories, the steel mills that ran continuously, the oil refineries that stretched to the horizon. In the weeks leading up to Pearl Harbor, Yamamoto had reportedly told Prime Minister Hideki Tojo that he could guarantee 6 months of victories, perhaps a year, but if the war extended beyond that, he held no confidence in Japan's ability to prevail. The strategic calculation behind the Pearl Harbor attack rested on a theory that Imperial Japanese Navy planners believed was sound. By destroying the American battle fleet in a single devastating blow, Japan would secure at least 12 to 18 months to consolidate its conquests in Southeast Asia and the Pacific. During this period, Japan would fortify a defensive perimeter stretching from the Aleutian Islands through the central Pacific to the Dutch East Indies. When America eventually rebuilt its fleet and attempted to cross the Pacific, Japanese forces operating from interior positions with land-based air support would inflict such catastrophic losses that American public opinion would force negotiation rather than continue a bloody war of attrition. This theory contained a fundamental flaw that would prove fatal. It assumed that American industrial capacity, while substantial, operated under the same constraints that limited Japanese production. Japanese war planners understood that America possessed more factories, more steel mills, and more oil wells than Japan. What they fundamentally failed to grasp was that American industrial capacity was not merely larger in degree but different in kind. The systems, methods, and organizational approaches that American industry had developed during the 1920s and 1930s had created manufacturing capabilities that operated according to principles Japanese military minds simply could not conceive. The Japanese military establishment's contempt for American industrial power was not rooted in ignorance of American economic statistics. Japanese intelligence services maintained detailed records of American steel production, oil output, and manufacturing capacity. The numbers themselves were not in dispute. What Japanese military leaders disputed was whether industrial capacity could be effectively translated into military power quickly enough to matter in the war they were planning to fight. This distinction is crucial to understanding the magnitude of their miscalculation. Throughout the 1930s, as Japan prosecuted its war in China and prepared for wider conflict, Japanese military planners studied American industrial capacity with considerable attention. They noted that America produced approximately 5 times as much steel as Japan, extracted 10 times as much oil, and generated vastly more electrical power. These statistics were acknowledged in Japanese planning documents. However, Japanese analysts consistently concluded that raw productive capacity meant little without the specialized expertise, organizational discipline, and industrial culture required to transform civilian manufacturing into military production. This analysis was not entirely unreasonable based on historical precedent. The conversion of civilian industry to military production had traditionally been a slow, difficult process requiring years of preparation and resulting in significant inefficiency. Automobile factories could not simply begin building tanks without extensive retooling, retraining, and reorganization. Civilian shipyards that built merchant vessels could not immediately construct complex warships without acquiring specialized knowledge and equipment. Based on every historical example of industrial mobilization, Japanese planners believed that America's vast but primarily civilian industrial base would require at least 3 to 5 years to convert effectively to military production. Japanese military culture reinforced this analytical bias. The Imperial Japanese Navy prided itself on craftsmanship and specialized expertise. Japanese warships were individually built by skilled workers using methods that emphasized quality over quantity. Each vessel was treated as a unique creation, with components hand-fitted and carefully inspected. This approach produced ships of exceptional quality. Japanese destroyers were widely regarded as the finest in the world. Japanese torpedoes were technologically superior to anything the Americans possessed in 1941. Japanese naval architects had designed battleships and carriers that matched or exceeded their American counterparts in combat capability. This emphasis on craftsmanship created a cultural framework through which Japanese officers evaluated industrial capacity. From their perspective, building warships required not just factories and steel but expertise that took years to develop. The specialized knowledge possessed by workers at Kure Naval Arsenal or Yokosuka Naval Yard represented decades of accumulated experience. American shipyards, they believed, lacked this specialized culture. American workers were seen as adequate for mass-producing simple consumer goods but unsuited for the precision work required in modern warship construction. This assessment appeared validated by America's industrial performance during the 1930s. Despite massive unemployment during the Great Depression, American industrial production had remained largely civilian in focus. While Japan was building carriers and battleships throughout the decade, American naval construction had been limited by treaty restrictions and congressional reluctance to fund military expansion. Japanese observers noted that American shipyards completed vessels slowly and often over budget. The few American warships launched in the late 1930s had required construction times comparable to Japanese vessels, suggesting that American shipbuilding operated under similar constraints to Japanese yards. What Japanese analysts failed to recognize was that American industrial methods were fundamentally different from Japanese approaches in ways that became apparent only under the pressure of mass production. During the 1920s and 1930s, American manufacturers had revolutionized production through techniques that Japanese industry had not adopted. Henry Ford's development of the assembly line for automobile production had created a template that other American industries adapted and refined. The concept of interchangeable parts manufactured to standardized specifications had become deeply embedded in American manufacturing culture. These innovations seem obvious in retrospect, but they represented a fundamental reconceptualization of how complex products could be manufactured. Traditional craftsman-based production treated each item as unique, with components custom-fitted during assembly. This approach maximized quality but inherently limited production speed. American mass production methods inverted this logic. By investing heavily in precision tooling and standardized designs, American manufacturers created systems where components could be produced in separate facilities and assembled rapidly without custom fitting. The implications of this difference were not immediately apparent in peacetime. When producing limited quantities of complex products, both approaches yielded similar results. Japanese craftsman methods and American mass production techniques both produced high-quality warships when construction rates were measured in 1 or 2 vessels per year per shipyard. The revolutionary advantage of American methods became visible only when demand required production at scales that overwhelmed traditional approaches. In early December 1941, American industrial mobilization was already underway but had not yet achieved the dramatic production rates that would characterize 1943 and 1944. President Franklin Roosevelt had declared America the arsenal of democracy and had secured congressional approval for massive expansion of military production. However, the actual conversion of civilian industry to military purposes was proceeding gradually. Automobile factories were beginning to retool for tank and aircraft production. Shipyards were expanding their facilities and hiring additional workers. But finished products were not yet flowing from these facilities in quantities that would alarm Japanese planners. The attack on Pearl Harbor transformed gradual mobilization into desperate urgency. The destruction of 8 battleships eliminated America's battle line in the Pacific. While most of the battleships would eventually be raised and returned to service, this process would take years. In the immediate aftermath of Pearl Harbor, the United States Pacific Fleet consisted primarily of aircraft carriers that had fortunately been at sea during the attack, along with cruisers, destroyers, and submarines. This force was completely inadequate to challenge Japanese naval dominance across the vast Pacific theater. The strategic situation facing American military planners in December 1941 appeared nearly hopeless. Japan had achieved total surprise and inflicted devastating losses. Japanese forces were advancing rapidly throughout the Pacific and Southeast Asia. The Philippines were under assault. Wake Island would fall within weeks. Guam had already been captured. Hong Kong was besieged. Malaya was being overrun. The Dutch East Indies were threatened. Japanese naval and air forces dominated an area stretching thousands of miles across the Pacific. American forces in the region were isolated, outnumbered, and facing defeat in detail. Against this backdrop of military disaster, American industrial mobilization accelerated with unprecedented speed. Within weeks of Pearl Harbor, the conversion of civilian industry to military production shifted from gradual transition to wholesale transformation. Automobile factories that had been slowly retooling for military contracts completely halted civilian production. The last civilian automobile rolled off American assembly lines in February 1942. From that point forward, facilities that had produced millions of cars annually devoted themselves entirely to military production. The shipbuilding program that would ultimately doom Japanese hopes centered on aircraft carrier construction. The Pearl Harbor attack had demonstrated conclusively that carriers, not battleships, would determine naval supremacy in the Pacific War. Japan entered the war with 10 aircraft carriers of various sizes, the most powerful carrier force in the world. The United States had 7 carriers in December 1941, but 3 were in the Atlantic. The 4 Pacific carriers represented America's primary naval striking force, and they were vastly outnumbered by Japanese naval aviation. American naval leadership understood that winning the Pacific War required building carriers faster than Japan could match. Traditional shipbuilding methods made this goal appear impossible. The USS Enterprise, one of America's pre-war carriers, had required nearly 3 years to build from keel-laying to commissioning. At that construction rate, replacing losses and building numerical superiority would take a decade. Japan's carrier construction program was proceeding at similar speeds. The war would be decided long before traditional construction methods could produce the necessary ships. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The solution emerged from applying mass production principles to warship construction in ways that violated every traditional assumption about how complex military vessels could be built. The architect of this revolution was Henry Kaiser, an industrialist who had never built a ship before the war but understood mass production principles better than any traditional shipbuilder. Kaiser had made his fortune building dams and highways using innovative construction techniques that emphasized prefabrication, standardization, and parallel workflows. When the Navy desperately needed ships, Kaiser proposed applying these techniques to warship construction on a scale never attempted. Traditional shipbuilding was a sequential process. A ship was built from the keel up, with each section requiring completion before the next could begin. Components were brought to the shipway as needed and installed by skilled workers who custom-fitted each piece. This approach worked well for building small numbers of complex vessels but created inherent bottlenecks when attempting rapid production. Only one ship could occupy each shipway, and construction proceeded at the pace of the slowest critical task. Kaiser's approach inverted this logic. Rather than building ships sequentially on shipways, he proposed constructing major sections simultaneously in separate facilities. Entire bow sections, stern sections, and midships sections would be built as complete units including all internal systems. These sections would then be moved to the shipway and welded together in a matter of days rather than months. Meanwhile, the facilities that had just completed one set of sections would immediately begin constructing sections for the next ship. Navy traditionalists were horrified by this proposal. Welding major ship sections together had never been attempted on warships. The standard method was riveting, which required skilled workers and substantial time but produced joints that Navy engineers trusted. Welding was faster and required less skill, but Navy engineers worried about the structural integrity of welded joints under combat stress. Kaiser's proposal to build aircraft carriers using these revolutionary methods seemed to risk producing ships that would literally fall apart under the stresses of naval combat. The desperate strategic situation overrode these concerns. In early 1942, with American forces retreating throughout the Pacific and carrier losses mounting, the Navy authorized Kaiser and other shipbuilders to proceed with mass production techniques. The program focused on building Essex-class fleet carriers using standardized designs that could be mass-produced. Every Essex-class carrier would be identical, allowing components to be manufactured at facilities across the country and shipped to assembly yards. The Essex-class design itself reflected mass production principles. Rather than custom designing each carrier to maximize specific capabilities, naval architects created a standardized design that balanced capability with manufacturability. Components were designed for ease of production using available materials and equipment. The design specified standard steel sizes and shapes that mills could produce in quantity. Electrical systems, piping, and internal structures used standardized components that could be manufactured by suppliers who had never built ship components before. The program's scope was staggering. The Navy initially ordered 32 Essex-class carriers, more carriers than had been built by all nations combined in the previous 20 years. Each carrier displaced 27,000 tons, was 872 feet long, carried approximately 90 aircraft, and required over 3,000 crew members. These were not simple vessels. An Essex-class carrier contained millions of components, miles of electrical wiring and piping, hundreds of compartments, complex machinery systems, and sophisticated electronics. Building 32 such vessels using traditional methods would have required decades. The transformation of American shipbuilding capacity proceeded with shocking speed. Kaiser's Richmond shipyard in California went from empty land to producing Liberty ships in months. New shipyards were constructed along both coasts specifically for the escort carrier program. Existing naval shipyards expanded their facilities dramatically. Newport News Shipbuilding, the Brooklyn Navy Yard, and Philadelphia Naval Shipyard all undertook massive expansions. But the most dramatic growth occurred at facilities that had never built warships before the war. The key to rapid expansion was the prefabrication system. Rather than requiring skilled shipwrights to fabricate components at the shipyard, manufacturers across America produced standardized sections that arrived at shipyards ready for installation. A factory in Kansas that had never seen ocean water manufactured ventilation systems for carriers. A plant in Ohio produced propeller shafts. Electronics firms in New York and California built radar systems and communication equipment. This distributed manufacturing approach transformed carrier construction from a specialized craft performed at a handful of naval arsenals into a national industrial effort involving thousands of facilities. The workforce required for this expansion grew from thousands to hundreds of thousands within months. Shipyards that had employed 5,000 workers in 1940 employed 50,000 by 1943. This dramatic expansion required recruiting and training workers who had no shipbuilding experience. Many had never worked in industrial settings before. The workforce included large numbers of women who entered industrial work for the first time, performing welding, riveting, and assembly tasks previously reserved for men. Training this vast workforce in months rather than years required systematic approaches to skill development. Complex tasks were broken down into component steps that could be learned quickly. Welding, traditionally a skill requiring years of apprenticeship, was taught in weeks through focused training programs that emphasized the specific techniques needed for ship construction. Quality control systems were implemented to catch errors without requiring every worker to possess comprehensive expertise. This systematization of skill represented another application of mass production principles to what had been a craft-based industry. The results began appearing in 1943. The first Essex-class carrier, USS Essex herself, was commissioned in December 1942 after a construction period of 20 months from keel laying. This was already faster than pre-war carriers, but it was merely the beginning. As shipyards refined their processes and workers gained experience, construction times plummeted. By 1944, Essex-class carriers were being launched less than 15 months after their keels were laid. Some were commissioned in barely a year. The quantitative impact was staggering. By the end of 1943, America had commissioned 10 new Essex-class fleet carriers. Another 14 would commission in 1944. In parallel, shipyards were producing light carriers converted from cruiser hulls and escort carriers built on merchant ship designs. The escort carrier program was even more dramatic than the Essex program. These smaller carriers, built primarily for anti-submarine warfare and amphibious support, were being launched at rates that seemed impossible. At peak production, American shipyards were commissioning an escort carrier every week. When intelligence reports about American carrier production reached Tokyo, Japanese naval staff initially dismissed them as propaganda or misinterpreted data. The numbers simply made no sense within the framework of shipbuilding as Japanese engineers understood it. A nation could not build aircraft carriers in 12 to 15 months. Such vessels required years of careful construction by skilled craftsmen. The American claims had to be exaggerated or had to refer to small coastal vessels being mischaracterized as carriers. Japanese intelligence officers investigating these reports discovered that American production claims were not exaggerated but understated. America was not merely building carriers quickly but was building them in quantities that overwhelmed Japanese comprehension. By mid-1944, the United States was operating more aircraft carriers than Japan had possessed at the start of the war. And American production was accelerating while Japanese shipyards struggled to replace losses. The mathematical reality of American production capacity began revealing itself through combat results in the Pacific Theater throughout 1943 and 1944. Japanese naval commanders found themselves facing an opponent whose losses seemed to have no lasting impact on operational capability. American carriers damaged in battle would withdraw for repairs and return to service within months. American carriers sunk in combat would be replaced by new vessels within the same time frame. Meanwhile, Japanese carrier losses were irreplaceable catastrophes that permanently diminished the combined fleet's striking power. The Battle of Midway in June 1942 had demonstrated this asymmetry in its starkest form, though its full implications would not become apparent for another year. Japan lost 4 fleet carriers in a single day, vessels that represented years of construction effort and embodied irreplaceable expertise in carrier operations. The United States lost 1 carrier, USS Yorktown, which had already been damaged at the Battle of Coral Sea the previous month. While both sides claimed victory based on various metrics, the underlying industrial mathematics told a different story. Japan had lost 4 carriers it could not replace within any relevant time frame. America had lost 1 carrier from a production pipeline that would deliver dozens more. The crucial distinction was not simply that America could build more ships but that American industrial methods had transformed shipbuilding from a specialized craft into a mass production process. This transformation had occurred so rapidly that Japanese intelligence services struggled to believe their own reports. The concept that aircraft carriers, among the most complex military systems ever created, could be manufactured using assembly line techniques seemed to violate fundamental principles of engineering and craftsmanship. Japanese naval architects and engineers who examined American production claims conducted detailed analyses attempting to identify flaws in the reported data. They calculated the number of man-hours required to construct a carrier using traditional methods and compared these calculations to the construction times Americans were claiming. The mathematics appeared impossible. Even accounting for larger workforces and longer shifts, the reported American construction times seemed to require productivity levels that exceeded any known industrial capability. What Japanese analysts failed to grasp was that American mass production methods had eliminated much of the labor that traditional shipbuilding required. Prefabrication meant that components arrived at shipyards already manufactured to precise specifications, requiring only installation rather than on-site fabrication and custom fitting. Standardized designs meant that workers could specialize in specific tasks and develop extraordinary efficiency through repetition. Parallel production streams meant that multiple ships could progress through construction simultaneously rather than sequentially occupying limited shipway capacity. The comparison between Japanese and American carrier construction methods illustrates the fundamental differences in approach. When Japan laid down a new carrier, skilled workers at naval arsenals would begin constructing the vessel from detailed plans that specified thousands of unique components. Each component would be fabricated on-site or by specialized suppliers, brought to the shipway, and carefully fitted into place. Quality control emphasized craftsmanship, with experienced workers inspecting joints and connections to ensure they met exacting standards. This process produced superb vessels but inherently limited construction speed. American Essex-class construction proceeded according to completely different logic. The design specified standardized components that could be manufactured by suppliers across the country who had never previously built ship components. A manufacturer in the Midwest would produce ventilation ducting to exact specifications without understanding how it would fit into the overall ship design. That ducting would arrive at the shipyard ready for installation, with mounting points and connections standardized so that any worker who had completed basic training could install it correctly. Quality control emphasized measurement and testing rather than craftsmanship, with standardized procedures ensuring that components met specifications regardless of which supplier produced them. This distributed manufacturing approach solved several problems simultaneously. It eliminated bottlenecks that occurred when specialized suppliers could not keep pace with demand. It allowed rapid expansion of production capacity by bringing new suppliers into the program without requiring them to develop comprehensive shipbuilding expertise. It enabled parallel production of components for multiple ships simultaneously, with different facilities working on sections destined for different vessels. Most importantly, it transformed carrier construction from a process that required years of specialized expertise into one that could be learned in weeks through focused training. The scale at which this system operated exceeded anything Japanese planners had imagined possible. By 1944, the American carrier construction program involved thousands of suppliers across the country. A single Essex-class carrier contained components manufactured in over 40 states. The electrical systems came from firms in New York and Massachusetts. The propulsion machinery was built in facilities in Pennsylvania and Ohio. Armor plate was rolled in steel mills in Indiana and Alabama. Aircraft elevators were manufactured in California. This distributed production meant that no single facility represented a critical vulnerability, and damage to any individual site would have minimal impact on overall production rates. The workforce requirements for this industrial mobilization were staggering. American shipyards employed over 1.7 million workers by 1944, a tenfold increase from pre-war levels. This expansion required recruiting and training workers at rates that seemed impossible by traditional standards. Shipyards that had employed several thousand skilled craftsmen before the war now employed tens of thousands of workers, most of whom had no previous shipbuilding experience. Women comprised a substantial portion of this workforce, performing welding, assembly, and quality control tasks that had been exclusively male occupations before the war. Training this vast workforce required systematic approaches to skill transfer that broke complex tasks into learnable components. Welding training programs condensed years of traditional apprenticeship into weeks of focused instruction on specific techniques needed for ship construction. Workers learned to weld the particular joints used in ship hulls and superstructures without necessarily understanding the full range of welding applications. This specialized training enabled rapid skill development while maintaining quality standards through systematic inspection and testing procedures. The results of this industrial mobilization became visible in commission dates that seemed to accelerate impossibly. USS Essex commissioned in December 1942 after 20 months of construction. USS Yorktown, second of the class and named for the carrier lost at Midway, commissioned in April 1943 after 18 months. USS Intrepid commissioned in August 1943 after 16 months. USS Hornet, named for another carrier lost in 1942, commissioned in November 1943 after 15 months. By 1944, construction times had dropped below 14 months, with some carriers completing in barely a year from keel laying to commissioning. Each commissioning ceremony represented not just the completion of a single ship but validation of industrial methods that traditional military cultures found incomprehensible. When USS Bunker Hill commissioned in May 1943, she was the 8th Essex-class carrier to join the fleet in barely 6 months. The Pacific Fleet was receiving new carriers faster than it could train air groups to operate from them. The bottleneck in American naval expansion had shifted from shipbuilding capacity to pilot training and aircraft production, problems that were being addressed through the same mass production methods that had revolutionized shipbuilding. The parallel expansion of American aircraft production created a synergistic effect that multiplied the impact of carrier construction. Building carriers rapidly was militarily useless without aircraft to operate from them. American aircraft production had undergone the same mass production revolution as shipbuilding. Factories that had produced thousands of civilian aircraft per year converted to military production and began delivering fighters, dive bombers, and torpedo bombers at rates that exceeded total Japanese aircraft production across all types. By 1944, American factories were producing over 96,000 aircraft annually, more than 8 times Japanese production. This disparity meant that American carriers not only outnumbered Japanese carriers but operated with full air groups while Japanese carriers increasingly went to sea with partial complements due to aircraft shortages. The combination of superior numbers of carriers and superior numbers of aircraft created compound advantages that no amount of tactical skill could overcome. The human cost of this industrial transformation was substantial though rarely acknowledged in discussions of production statistics. Shipyard workers labored under dangerous conditions with inadequate safety measures by modern standards. Industrial accidents were common, with workers killed or maimed by falling steel, welding accidents, and machinery failures. The pressure to maintain production schedules meant that safety concerns were often subordinated to speed. Night shifts worked under artificial lighting that was inadequate for precision work, increasing error rates and accidents. The psychological stress of maintaining intensive production pace for years took its toll in elevated rates of illness, family disruption, and worker burnout. Yet despite these hardships, the workforce maintained productivity levels that continued to improve throughout the war. This sustained effort reflected not just patriotic motivation but the effectiveness of industrial organization that made individual contributions visible and meaningful. Workers could see carriers taking shape from their efforts, could track construction progress against published schedules, and could read news reports about ships they had built engaging in combat operations. This direct connection between individual labor and strategic outcomes created motivation that sustained effort through years of difficult conditions. The contrast with Japanese industrial conditions was stark. Japanese workers labored under similar physical demands but without the organizational systems that made American production so effective. Japanese shipyards continued using traditional methods that relied on skilled craftsmen working with inadequate materials and obsolescent equipment. As the war progressed and American submarines interdicted Japanese shipping, raw material shortages became critical. Steel quality declined as alloys became unavailable. Critical components had to be salvaged from damaged ships rather than manufactured new. Worker morale suffered as the impossibility of matching American production became apparent. Japanese carrier construction continued throughout the war but at rates that made replacement of losses impossible. The carrier Taiho, one of Japan's most advanced designs, required nearly 2 years to build and commissioned in March 1944. She was sunk 3 months later by an American submarine. The carrier Shinano, converted from a Yamato-class battleship hull, required over 3 years to complete and was sunk by a submarine 10 days after commissioning, before ever conducting flight operations. These losses were irreplaceable catastrophes for the Imperial Japanese Navy. By contrast, American carrier losses, while tragic for the men who died aboard them, had minimal strategic impact. When USS Princeton was sunk during the Battle of Leyte Gulf in October 1944, she was one of 9 Essex-class carriers participating in the battle. Her loss reduced American carrier strength in the engagement by 11%. Within 2 months, newly commissioned carriers had more than replaced her capability. The mathematics of industrial warfare had made American carriers functionally expendable, a term that would have been unthinkable at the start of the war when each carrier represented a significant portion of total naval aviation capability. The Essex-class program represented only part of American carrier production. In parallel, shipyards were producing Independence-class light carriers converted from cruiser hulls and massive numbers of escort carriers built on merchant ship designs. The escort carrier program demonstrated mass production principles applied with even greater intensity than fleet carrier construction. These smaller carriers, designed primarily for anti-submarine warfare and amphibious support, were being launched at rates that seemed impossible even by the standards of Essex-class production. Kaiser's shipyards were completing escort carriers in an average of 3 months from keel laying to launch. At peak production in 1944, escort carriers were being commissioned at a rate of 1 per week. These were not simple vessels. An escort carrier displaced 11,000 tons, carried 30 aircraft, and required crews of nearly 900 men. Yet American shipyards were building them faster than Japan could build destroyers. The escort carrier program alone produced 122 vessels during the war, more carriers than Japan built across all types throughout its entire naval history. The strategic implications of this production disparity became undeniable during the Philippine Sea Campaign in June 1944. American carrier task forces operating in support of the Marianas invasion comprised 15 fleet and light carriers, more carriers than Japan had possessed at any point during the war. These carriers embarked over 900 aircraft, outnumbering Japanese naval aviation by nearly 3 to 1. The resulting Battle of the Philippine Sea, known to American pilots as the Great Marianas Turkey Shoot, saw Japanese naval aviation effectively destroyed as an offensive force. American fighters shot down over 600 Japanese aircraft in 2 days while losing fewer than 130 of their own. The Japanese could not replace these losses. Pilot training programs that had produced superb aviators before the war had been overwhelmed by attrition. Replacement pilots received minimal training before being sent into combat against American aviators who had months of flight training and combat experience. Japanese aircraft production, while substantial in absolute terms, could not match losses. Most critically, the carriers that might have provided platforms for rebuilding naval aviation were either sunk or lacking aircraft and pilots to operate effectively. American losses in the same engagement were replaced within weeks. Damaged carriers returned to Pearl Harbor or West Coast shipyards for repairs and were back in action within months. Lost aircraft were replaced from production lines delivering hundreds of new planes weekly. Pilot losses, while tragic, were absorbed by training programs graduating thousands of new aviators. The industrial advantage had created operational advantages that compounded over time. Each engagement that inflicted equal percentage losses on both sides left America relatively stronger because replacement capacity was so asymmetric. The final vindication of American industrial methods came during the Okinawa Campaign in 1945. American carrier forces operating off Okinawa faced sustained kamikaze attacks that damaged dozens of ships and sank several escort carriers. These attacks, while causing substantial casualties, had minimal strategic impact. Damaged carriers were replaced by newly commissioned vessels. The campaign proceeded on schedule despite losses that would have been crippling earlier in the war. Japanese commanders who had expected kamikaze tactics to inflict unsustainable losses discovered that American industrial capacity could absorb damage rates that would have destroyed any other navy. By August 1945, when Japan surrendered, the United States Navy operated 28 fleet carriers, 9 light carriers, and over 70 escort carriers still in service. Dozens more were under construction or fitting out. This armada represented industrial capacity applied with systematic efficiency over 4 years. The Japanese generals who had mocked American industrial potential in 1941, dismissing it as irrelevant to military power, had witnessed the most comprehensive demonstration of industrial warfare in history. Their contempt had been replaced by despair as the gap between Japanese capability and American production widened beyond any possibility of closing. The story of American carrier production during World War II demonstrates several profound truths about innovation, industrial organization, and the relationship between industrial capacity and military power. First, it shows that revolutionary capability emerges not from incremental improvement but from fundamental reconceptualization of processes. American shipbuilders did not build carriers faster by working harder using traditional methods. They achieved revolutionary speed by abandoning traditional methods entirely and applying mass production principles that experts claimed were impossible for complex military systems. Second, the carrier production program demonstrates that expertise and tradition can become obstacles to innovation when circumstances change dramatically. Japanese naval culture's emphasis on craftsmanship and specialized expertise produced excellent ships built slowly. This approach was optimal for peacetime naval competition and limited war. It became catastrophically inadequate when confronted by an opponent who had industrialized warfare itself. The accumulated expertise of Japanese shipbuilders became irrelevant when American production methods rendered traditional construction approaches obsolete. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.